There's a lot of geometry stuff on yesterday's assignment that I want to go through. First of all, there's a couple of geometric proofs. The first one being that if AC and EC are congruent and BC and DC are congruent, prove that AB and DC are congruent. So just to clarify our picture a little bit, we have that AC and EC are congruent, so this side and this side. We also have that BC and DC are congruent, so these two sides have the same length. And we want to prove that AB and DE are congruent. So let's start off with AC being congruent to EC. All right, that was given. We also have that ACB is going to be congruent to ECB. So ACB, this angle, and this angle, they'll be congruent to each other because they're vertical angles. We also have that BC is congruent to DC, which was also given. That means that our two triangles are congruent to each other, ABC and ECD, or EDC. And that's going to be because in each triangle we have congruent sides, angles, and sides. So sides, angles, and sides. So by SAS, we have that these two triangles are congruent. If they're congruent, then their corresponding parts are going to be congruent as well, which means AB is congruent to DC by CPCTC. In this next one, we're given that two pairs of sides are congruent, and we want to prove that two angles are going to be congruent. So we're given that GE and GH are congruent to each other, and that EF and HF, they're congruent to each other as well. And we want to take a look at these angles E and H. Okay. Well, to start off, we know about GE being congruent to GH because that's what's given. The other thing that was given is EF being congruent to HF. Now we also know that GF has to be congruent to GF. Okay. That this third side, since both triangles share that side, it has to be its same length. That's by the identity. That something has to be as big as itself. With those three things now, we know that our two triangles are congruent. The GEF is going to be congruent to triangle GHF. Because what we have here are all three sides in both triangles being congruent. That means that all three angles are going to have to match up as well. So angle E is going to be congruent to angle at H by CPCTC. Now, in these proofs, I've used a few abbreviations that you should be familiar with from geometry. However, it's been a while, so you might not remember them. For instance, CPCTC, I use that in both proofs. It means corresponding parts of congruent triangles are congruent. That's why when we have two congruent triangles, we can match up their sides. They're going to be all congruent to each other. We can match them in pairs. And we can also have corresponding pairs of angles be congruent as well. I used SAS, and that meant side, angle, side, so that if I could show that two pairs of sides and their included angles were all equal to each other, congruent to each other, then we had two congruent triangles. SSS, of course, meant side, side, side. So if all three pairs of corresponding sides were congruent, so were their triangles. Now here are all of the permutations of S's and A's, to have three of them in a row. SSS, AAA, the 3 permutations of having just one S and the 3 permutations of having only one A. Now, of course, all of these I'm talking about side, 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 angle, 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 side, angle, 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 side, angle, 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 side, angle, side, 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 angle, side, and side, side, angle. All right. Not all of these are going to be congruency theorems. Only a few of them are. First of all, as we look through this list, we have a couple of them that mean the exact same thing. For instance, SAA and AAS, side, angle, angle, and angle, angle, side. Now, because the direction that we move around a triangle doesn't really matter, side, angle, angle, and angle, side, side are exactly the same thing. So we don't need to list them twice. And that's the same thing with angle, side, side, and side, side, angle. They mean the same thing. So we've just reduced our list from 8 down to 6. But there's still 2 more of these that don't count as well. And that's going to be angle, 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 and angle, side, side. So there are only 4 congruency theorems. Side, 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 angle, 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 side, angle, and side, angle, side. So which one could we use to prove congruency in each of these 6 diagrams? Well, in the first one, we can tell that these 2 sides are going to be equal to each other. We are also told that both of these are right angles, so we got a side and an angle. And then they share the same altitude right here. So we have a side, 2 sides actually, and an angle. The only one that has that is side, angle, side. And we have to make sure that the angle we're given is included in between those 2 sides. In the second diagram, we see that we have 2 sides that are the same. These 2 sides are also congruent, and they share a third side. We don't know anything about their angles, but we do know that all of their sides have another side in the other triangle that they match up with. That would be side, side, side. In the third diagram, we're given that this pair of sides are equal to each other, and this pair of sides is congruent to each other as well. And since they share this side in the middle, that side is the same length in both triangles as well. So once again, we're given side, side, side. On the bottom row, look at what we're given, and the things that we're given are 2 sides that are equal. We're also given that 2 angles are equal. So I have something with 1 side and an angle. That could be any of those last 3. So we need to find out about either another angle or another side. And since these 2 angles are vertical angles, that would mean that they're going to be congruent to each other as well. So we have a side here, and an angle here, and an angle here. Now, is that angle, side, angle, or angle, angle, side? Well, you have to connect them in order. All right, so going this way or the other way. That would mean side, angle, angle, or angle, side, side, angle, side, side being the correct answer. The next one, 2 angles that are congruent, and these 2 angles are congruent. They also share this side down the middle. So we're given an angle and a side and an angle. So once again, a diagram where we have 2 angles and a side, but this time it's the side that is in between the 2 angles, that being angle, side, angle. Last one, 2 sides are congruent. These 2 sides are congruent, and they also have vertical angles here. So we have a side and an angle and a side. How about these 2 triangles? Are they congruent? It should be obvious that they're not, since congruent means equal. These 2 are definitely not the same triangles. But take a look at what we're given. If you notice, we're given that these 2 angles are congruent to each other. And when it comes to sides, we have a pair of sides that are congruent and another pair of sides that are congruent. So we're given 2 sides and an angle. But it's because that angle is not the included angle, that's what allows this red side to either be over here or over here. It could have the same length whether it's swung out this way or inside this way. There's nothing that locks it in place like having the angle included in the middle. And that's why angle side side is not one of the congruency theorems. We could possibly end up with two separate triangles in those pairs of congruencies. And how about these two? Are they congruent? Well, if you look at what we're given, it looks like we have two equilateral triangles. So all three angles in the first triangle are 60 degrees, as well as in the second triangle. All three angles are 60 degrees. But because we don't have any pairs of sides that are congruent from triangle to triangle, we have two triangles that are similar, but they're not congruent. We have a bigger one and a smaller one. And this is the reason that side, side, side is not a congruency theorem. So we have four congruency theorems that we can use, but it's angle side, side, and side, side, side that we cannot.